So in this video, we want to find the optimal values of the function f of x equals b minus e to the negative x minus a, the quantity squared, over all reals, where a and b are just constants greater than 0. So we're going to do our normal steps. First thing we're going to do is we're going to take the derivative so we can see if there's any critical points. The derivative of b is 0. So really, we're just looking at the derivative of this part, and it's the derivative of an exponential, which is itself, and then we'll multiply, because this is a chain rule, times the derivative of the exponent, which is going to be another chain rule. First thing we're going to do is we're going to pull that 2 out in front, so -2, leave the inside alone, decrease the power by 1, times the derivative of the inside of this one. Well, the derivative of x is just 1. So there is our derivative. Let's clean it up just a little bit. So we have a negative and a negative. That'll be a positive. And so we'll pull the 2 times x minus a out front, e to the negative x minus a quantity squared. And because we're looking for critical points, we set that first derivative to 0. This exponential piece will never be 0. 2 will never be 0, so this is the only thing that can be 0. So x minus a equals 0, very easy to solve. We get x equals a. There is our critical point. Now, we want to see what's happening at this critical point. So we evaluate our function at the critical point, and we get b minus e to the negative a minus a, the quantity squared. Well, what's going to happen here? A minus a is 0. 0 squared is 0. Negative 0 is 0. We get b minus e to the 0. This just comes out to be b minus 1. Now, we are not on a closed bounded interval, so we lose the property that we're guaranteed both an absolute max and an absolute min. So one thing we might want to do for this function is look at the graph. So here we see our graph, and we can clearly see we have a minimum. Now, right now, I've got my parameters both set to 1, and we saw that our critical point was at a. So here's our b minus 1. Remember, b is set to 1. 1 minus 1 is 0. So that's the point 1, 0, given our parameters. So we clearly have a global min. So we clearly have a min at b minus 1. And what we see is if we move our parameter a, wherever a goes, our minimum goes. Now, a was greater than 0, so we're only looking over here at the right half. So a is where our minimum is. B is going to give us our minimum. Because b minus 1 gives us our minimum value, changing b changes what our minimum is. Now, what we see going on at the top is we've got a horizontal asymptote. Essentially, if we move b back to 1, you'll be able to see it at 1 or at b. So we do not have a maximum. Because as we saw from the graph, this is going to just keep heading closer and closer to 1 as we go to infinity in the positive and negative direction. So we have a minimum. It occurs at a, and it's equal to b minus 1. That's this right here, our critical point. But there is no max because we have a horizontal asymptote at b, which tells us that as x goes to infinity in the positive or negative direction, the function goes to b.